difference between these two pictures. This one is right before the diamond ring. This one is a little bit ahead of it. And everything, look, they're the same, they're obviously the same thing. But look how different the information is. And that's the kind of thing you want to record. This was the prominence that we saw at the very beginning of the eclipse. Remember? That one. So, in other words, get the best image of what you want, figure out what you want to try to shoot, and you bracket the exposures. Don't bracket more than you need to bracket, but different exposure times or different f-stops will give you more or less light hitting your camera, and you have to play with that. But at the same time, I just don't stop shooting, right? Especially right at the beginning of the eclipse and the end, because so much changes so fast. We think the corona is going to be more round because we're nearer to sunspot maximum, as opposed to being a long corona like this. That's good. More corona. Okay, now, next bit of information. I found this picture. This was 1991 I shot, and this was very cool because the prominence was up there. But the point is, it was kind of connected. The point is that how big an image depends upon two things, not just one. It depends upon what your camera is shooting, how big is your imager, and what lens you put on it. So if you're shooting one of these new cameras, it's light and it's 24 megapixels, you think, oh, it's going to be the same as this one. Wrong. This one's got a much bigger imager. So you can see how you have to plan. You're seeing the sun's going to be the same size, but it's going to look much bigger in this picture than it does in this one. And that's how the difference in, do I want full frame or do I want the DSLR reduced frame images? And this one is you don't want to get that close to the edge. But and the other thing is, the bigger the sun, the bigger the eclipse, the harder it is to deal with the Earth's rotation, because you've magnified the rotation as well. So you have to figure out how big an image can you keep in, and you can do that by trying to photograph the moon. Are you happy with what you're doing looking at the moon? And this is true just for observing it. Let's say that I'm not going to photograph anything. I'm just going to put an eyepiece on this old telescope of mine, and I'm going to observe through that. Fine. But which eyepiece size do I use? One that I can keep the image in. So that you have to think about it there too. Now this is an example of stuff. First of all, this is the filter, solar filter. I put around it a piece of a koozie, the koozie material that you make drink koozies, so that I could get this thing taken off without jarring the telescope. Because one of the other things you don't want to do is to have to yank your filter off and knock the sun off. Then you can't find it, and then you're panicked, and it's only got 4 minutes, you're not going to make it, and you can't get the sun anymore, and the sun's much fainter. And but if you didn't get the filter off, but you haven't to shoot, you really are in a bad mood. So practice taking off the filter. Now another thing you can do, you can have someone stand in front of the telescope, or hold a card in front of the telescope. Take the filter off early, so you really don't rush it. And then when they say, okay, second contact, drop. The person moves, or the screen he's holding up takes away, and you don't jar your telescope at all. The other thing is, if you decide you want to do an equatorial mount, the advantage of that being you set your latitude, ours is 30 in Houston, and you only have to guide in one axis. And you have to aim the telescope, can't quite see this, you have to aim the telescope toward the north, your rotation axis, that axis there. So you can do that if you want to. That's actually, on this telescope, it's actually coming right through here. But you can, if you get a telescope that has an equatorial mount, they'll tell you how to align it. But aligning in the daytime is a little tricky. It's nice to have a cell phone that gives you compass directions. But there's all of our, oh, and you need a hat. Adam recommends the cowboy hat. Henry chose the beak, and of course I chose the sloppy hat. My camera's there, my husband's cameras are there, telescopes are there, and all of the museum people are coming this direction. And most of that equipment is down front right now. This I thought was so impressive. This is Charles. Charles made all those really pretty pictures of the annular eclipse. And there it shows you through the camera. And then here's his camera. And he's got it hooked up to something that tracks at solar rate. It finds the sun and tracks it. Not cheap. But once again, are you going to have 10 uses for it? Then buy one. That is a special camera just to see the image of the sun in H-alpha of all things. And he got this hoodie thing. I've got one down front to show you where he put his computer and he's feeding the camera into the computer. So if you really are into this, or if you want to stream the video, if you have social media in your future or present, then a camera that will stream to your phone, will go to your computer, and your computer then can send it over on the web. Maybe that's worth spending all this money. But that's your decision. Here is a total eclipse. This is the same fisheye. I aimed it a little better this time. See, I'm tilted a little more so I don't have that lens flare. And this is everybody. You can see no one's too worried. Nobody settles down. Have you noticed? You think, oh, I'll just sit there and watch it. No, you won't. You run around like a crazy person. Look at all these people running around like crazy people. See, everybody's worried about it. They're making another picture. Oh, I got to get one more of these things. Oh, I don't have that. See how dark it is over here? The moon is coming that way. Covers the sun. More totality. More totality. With totality. My camera couldn't catch it. I did not change the exposure the entire time this movie was made. So I knew at the middle of totality I wouldn't be able to see anything. And there it comes back out. Cool? And everybody's still moving around. So it gives you an idea of how people behave. I wish I had recorded the sound, but this camera doesn't record it. We did kind of match it together. But have your cell phone, at least make audio, record the thing. Because the noises people made are very unusual. They never make these noises in normal behaviors. They're oohing and ahhing at a level that's quite awesome. So here's your idea, so you can see that is your sunset all the way around, or sunrise. 2 different pictures of it. This one has a really cool cloud that Pat calls a dragon. Now, you can collage pictures. Not too thrilled with this one, but it does illustrate a point. If you make several pictures with your same camera, you can layer them and see if you can make something that looks even more interesting. This is the only planet you can do this on, in case you're curious. You can go to the moon, and during a lunar eclipse on Earth, you'll have a solar eclipse on the moon, and your ground will turn red. That's worth thinking about. So that's the only other place really you can get an eclipse. And of course, every place else, your moons are too small. We are that's Phobos, by the way. That was made by Perseverance. Isn't that cool? That's Phobos crossing the sun. So these are real pictures, but they're not eclipses. If we define the eclipse as having one object covering another and they're both about the same size, we're the only place that's got one. And we're not going to have it forever. Now, the moon is pulling away from the sun, from the earth. So the moon is getting smaller. There will come a time when we will never have another total solar eclipse. We'll only have annular eclipses and partial eclipses. I think that's estimated about 6 million years from now, something like that. You probably have plenty of time now. The only thing that limits you is the number of different places you have to go to get these eclipses, unless you do this one, when all you have to drive is 4 hours west. That's getting there. 20 hours coming back, because everybody else is coming back. Okay, let's bring the lights up. Oh, no, I got one more thing to do. Never mind, I forgot. I want to talk about how you photograph the eclipse and with equipment, things you need to know, what your handout says. I want to go over the handout before I hold it up. First of all, during the eclipse, you have first contact. This you photograph with a filter, and then you have to be sure you like that. Then you're going to have second contact is when the moon completely covers the sun. Come on. Second contact, please. There we go. See how the slit, the vertical slit? Then there, and look how quick you're back with the sun again. Okay? So, I love this chart. No one's ever created anything more bizarre than this. If everybody remembers ISO, you can still set this on a cell phone, and you certainly can set it with the sensitivity of your, you've got this handout, by the way. You can pick out how sensitive your film is, how sensitive you are letting your pixels be. Then you go over here and you pick out the F number. So you're going to do it at ISO equivalent to 100, and you're going to shoot at f5.6. Then you go down, and that's the exposure it recommends for, don't forget those first two. For Bailey speeds, chromosphere, prominences, corona plus 0.1 solar radii, 0.2 solar radii, 0.5 solar radii, 1 solar radius on both sides, 2 solar radius, and give me a break. So, any rate, you can see how much more you have to expose. As you go down, I can't decide which one to do. Well, that's why you do them all. You aim the telescope at the eclipse, and you go click, 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 and make every exposure. Then you go back up again. And you'll get one picture that's great with prominences, another picture that's great with a corona. Cool. And as I said, you can skip an f-stop. Like you can go from F15 to 1/4, skipping the H, because it will, the shutter speed will compensate for it. You can take Photoshop or whatever, and you can adjust that much. When in doubt, underexpose. Once you've blown it out, you can't get it back. But if you've underexposed it, the image may still be there, and you can get it. So, now, how big do I want my image? You have this handout as well. Only one exposure. This is your focal length if you're shooting a 35 millimeter frame. If you're shooting the normal small lightweight cameras with the smaller imagers, you get this image with that millimeter focal length for your lens. So this gives you an idea. Over 2,000 millimeters, you've got a sun problem. It's bigger than your picture. And over 1,500 millimeters on the smaller cameras. So keep this, futz around with it. You want to buy now buying a telephoto lens is not a waste either, simply because you'll use it. There's birds in the trees and all kind of stuff. You'll start making pictures of. So that would not necessarily be a mistake, as well as much as some of the other stuff I've shown you. Then you've got to worry about field of view. Let's see, the sun is 67 degrees high. I want the sun and the horizon. Well, I could do a 20 millimeter. Works great with the standard format sensor. Oh my gosh, the digital sensor, that's all I can get. I'll have the sun at one top and the bottom will be the horizon. Maybe I go back to 14. See what I'm talking about here? This is the field of view of your frame, what's in it. And the bigger the field of view, the smaller the sun. And the longer you can keep the sun in. So, and the sun moves, since you know how fast the sun moves, then you can, 15 degrees an hour, then you can kind of fix back how fast you can do this. By the way, the sun's image, best simple equation, the sun's image size in millimeters is the focal length in millimeters divided by 109. Just for lack of a better number. So if you want that picture, there's a planet right, where is it? I can see it on this screen. It's right up there. There it is. So this might be the best picture you get. You could have a cowboy here, or a windmill, or something else that's pure Texan, and get the frame just right and make the picture. And that's easy to do, because you're doing a regular camera, basically, with that. So another idea. This one we think is a fake, but it gives you an idea. You might shoot a bunch of people, get behind them in such a way the eclipse is behind them, in front of them, and see what you get. But we think it's, but there's no sunrise in there, no sunset in there, so we don't think it's real. And that looks a little bit, nah, they didn't get that picture. You know? This is the best one of all. Now somebody every time wants to do this. It's one frame. The camera doesn't advance. Doesn't cause you not to overexpose. This is an overexposure of the tree. He shot all of these, and they all ended up on the same. Isn't that marvelous? So if you are really brave, I mean, this is, and you want it to be like this so you can document, you really pull this off. This is hard, to keep the camera in exactly the same place and get that picture. So if you want to try that, that's all the data you need, and you have to be certain. As it said, the sun moves its own diameter every 2 minutes. So you can get an idea how he did it. He figured out how far the sun would go during the entire eclipse. I have had people do this, and I've heard the horror when the edge of the frame is right here. Oh no, it's freezing! So they would cut off again. But whatever you want to do, this makes a really interesting, real photograph. But this will tell you how long to wait between exposures so that you get them, they don't overlap each other. And that's just one of the most awesome. That's real. I know the guy that did it. It's real, but it's just, wow. Or you can do this. We are all convinced you can't do this, but maybe you can. You have to get the cowboy to stand still. You have to get very far away, and then we're still not sure you can do this. But at any rate, it certainly is interesting. And maybe it will give you an inspiration, if nothing else. And now I'm going to go down front and talk about equipment. Okay, bring up the light so they can see your hand out. You want to join me, Adam? Sure. Since you were a victim of this as too? Okay. First of all, I did give all of the handout stuff. How are we doing time-wise? This is all the information that I showed in the data slide. These pictures that I showed are the pictures I showed. And this tells you how we shot them and what we shot them with. So I figured that's a useful handout. And we all made them at the last eclipse. Now, let's talk about this. Oh, we have to give these out, Adam. These are you can't wear them as glasses.
Right now, you want to hand them
Yeah,
out?
people are leaving. You gotta be sure they have them.
Want some glasses before you leave?
And the other things, this shows you a telescope, and it made some of the pictures. This is the SC60. And, huh? One per person.
Here's glasses.
That's a filter that goes, see, I told you it goes off easily, but if it didn't, I could make a filter out of the koozie, and it goes off even easier. And then binoculars. Here you go. See, there's your glasses cut in half, and they're on your binoculars. Now, what may be a good idea is not to do the binoculars. just wear them around your neck without any filters, but don't put them to your eyes. Then at totality go, oh. Because that's the part you're going to want to see big anyway. But if you really want, because now the problem is, how do I get these off? So that's where the binocular koozie comes in. This is the binocular koozie in these small, delicate binoculars. And that's the medium size. This is the fisheye lens that made the movie, the time-lapse movie. And it plugs into you power it with a power cord, so it runs out of power. You have to be sure it has enough frames in the card to capture the images. I didn't want to fall off, otherwise it did. But it's a 180 fisheye. These are your binoculars on a tripod. Now at 67 degrees high, this has got its own problems. That's why you practice on the moon. The time to practice on the moon, by the way, is February 22nd at 9:18, February 23rd at 10:20, or February 24th at 11 something. That's when the moon is going to be nearly full and as high as it's going to be at the eclipse. So you can also be sure this is going to work. Because this is one of those things, this looks so good until you go, uh-oh, how do I look at it? So you have to think, well, you can't hold these, they're so bloody heavy. So you have to think about whether you want to buy a pair of these or not. You can always use, of course, these. For your pinholes. You can make, if you're the natural side, you can make natural pinholes with fake trees. But it's springtime. Perhaps you want to use fake flowers. The goal is to make this fun and interesting and entertain the grandchildren. You can get a hat with the eclipse on it. My hat says 2045 because my family is going to take me to the eclipse in 2045 or whenever he is left. And these are cool. These are from, I think they're 10 power. You look in them like that. Small binoculars. And the museum is selling, I always forget to plug this. If you really feel like you have not gotten Slave and Devoner under control, I recommend these.
Ooh.
Whoa! In them you can see absolutely nothing but the eclipse. But the few moments that everybody sees you wearing these has got to be worth the exorbitant cost I think we're charging. So, I'll say one more time, we'll give it to Anna, and you can tell by these pictures. This complete setup here, all of it, including the camera, fits in here. So I can take it to Egypt, I hope, and wherever. So think about all of the different reasons you spend money on things and what you really need when you make a decision. You want to talk about that one?
Sure. Okay, so in 2017, I had two of these telescopes. These are Celestron C8, and then we attached the DSLR camera to each one. One had Canon and one had a Nikon, but one had a telecompressor, so that we saw more. The sun was smaller, but we saw more of the corona. And then one did not have a telecompressor, so that it was pretty full frame. And that's when you could see the prominence is a lot better and the Bailey speeds and stuff. But the coronal, total radius of it was kind of cut off. But so we had both going. But I like to make time-lapse movies, and so I was sure to have an intervalometer. Some cameras have intervalometers built in. Some you have to just buy a $20 external intervalometer so that it will take pictures on a regular basis. 1 a second or 1 a minute or whatever you want to do. And then I also would have, as Carolyn mentioned, a bracketed exposure so that if what I thought it would be is in the middle, it would take 2 a little bit underexposed and 2 a little bit overexposed. Because as it gets close to the end, the exposure is going to be changing a lot, drastically, right? And I didn't want to be futzing with it and miss it. So I had to, let me just get a whole swath of things. So it was just going, yeah, right, every second.
You need a big card.
Yeah. And you know, one of those 5 that it takes every second is going to be good. Some are going to be too bright, some are going to be too dark. But I didn't care because I was just taking as many as you could during those 5 minutes, right? Those precious 5 minutes that you got.
I bought a new camera because we opened our mouth and got into something. We're going to try to stream this thing, the Eclipse. We're working with NASA to do that. And any rate, it caused me to justify spending money. I got a white one so I can keep track of it with all the black ones I have. And it does produce an HDMI signal, which I can plug into my computer, and the computer's happy to have it. So would anything else be happy to have it. So you can use a camera like this, as I say, to do streaming, whatever, and you can buy lenses for it to get you a fairly nice magnification to the image. And you can test them out, and test them out and take someone back if you don't like it, if you don't like the size. But this is a small imager. I have found the small imagers give very sharp images, and I don't think that's a real problem unless you want the big imager because you want to shoot something and make it really big, then it's a different story. But at any rate, this is the kind of telescope you can use, and you just, to hook a telescope to hook a camera to a telescope, for big someone's here, you just treat, it's here somewhere. You hook this to it, and that goes right in the eyepiece. It's called a T adapter. So it just sits right on in there. If you're buying or have something like I have a telescope as well.
Yeah, same thing right here.
Yeah.
It's just an adapter to mount the.
And you can get a 2-inch tall, but this is for the Eclipse. This is fine. And you can get these T-rings that screw in to your camera, and they have them for every camera you can imagine. So. You want to, but you have to have a telescope to go with it, otherwise you don't need this. And somebody's selling this snapshot, that's what he called it, and I thought, nah, we're giving these people binoculars, we're giving these people things, they can just put them on. So, you know, you shoot your
Nice.
Isn't that cute? This doesn't get much cuter for your partial fadings. If you're so just, once again, this is cutting up your glasses. Besides getting your glasses, I will be glad to tear another one in half and give you one more if you want one for your cell phone. Any questions? Is there anything you could possibly waste money on that I haven't thought of? Oh, the times are in the little card.